So now that all our cluster nodes are running again, we'll click on node 1, and here we can see what's going on with the system. So here's the CPU usage graph, the network usage graph, the memory, and the disk. So it looks like the network is doing something, but the CPU hasn't done anything recently because we haven't run the MPI program. But I can demonstrate how this works by going back to the root node. And here we'll just move this to the side so we can see the CPU usage graph. And we'll run this again. We'll run it a few times just so we get some data in there. And we can see back on the summary that the CPU usage went up. The memory stays the same because this is a very small program, and there was a bit more network communication. So if we're interested in what processes are doing this, we can go view the running processes for the node. So here, by default, I've selected the top 100 processes. So that doesn't mean there was 100 processes running at any time. If we group by the timestamp, we can see that there are 23 processes running at each of the timestamps, and then we get 8 more just to make it to 100. So we'll just stop that grouping. We'll just sort by who has the most CPU time. So as we would expect, CPI, which is the demonstration application for the MPI, is using the most CPU time. Also, we can see Overseer Service. This is the service that's running the application. We can see that has 0 CPU time. So again, that shows how it's a minimal footprint, so we don't want to affect the performance of each cluster node with a monitor, and this shows that that is the case. So now we've seen the cluster summary, the node summary. Now there's a few administration tasks that we can do besides approving, enabling, disabling nodes. So we've seen that. Now we can see who are the valid users who can log on to this system. So this user is the one I logged on with. We don't see the password because of privacy information. And we see a few others I've created. We can add a new user to the system. Let's call this user ELEC 873. Oh, sorry, I'll give that no spaces for the username. We'll just give it a password of password. Display name is ELEC 873 course, and the email, we'll just call it fake@queensu.ca. So we see the user's been added, and one more thing I'll point out here is that all these fields are validated, so you have to enter something for the username here and the display name. And if you just put test for the email, it doesn't say it's valid, because a email has to have, the domain and everything associated with it, and this program prevents people from entering bad data into the database. So the last thing we can do as an administration task is we can export the data that we've collected using the monitor to an Excel file. And this is useful for monitoring the stuff as a long statistical analysis rather than the high-level current analysis that we can get from the other pages. So first we'll export the cluster nodes themselves. So here we can see the cluster node names and importantly the IDs, and I'll show you why that's important in a second. I'll just save this to my desktop. And we'll just call it nodes, and we'll close that. And now that we have the IDs for reference, if we want to see what the network usage was, we can see here the node ID and bytes received and bytes sent and the time at which it happened. So this is a little different than what we see on the node page. The information we can get from the server is the total number of bytes and bytes sent and received during the session. So we see all the different node IDs here. We can easily analyze that later. But to remind you, if we go back to the summary for, say, node 1, the network doesn't show bytes sent and received. It shows bytes transferred in terms of bandwidth. And the way this is calculated is we take the bytes sent and received and compute the difference between the timestamps and divide by the difference in time. So then we get the data transferred per time unit. So I can actually show you, if I go on to node 1 here, I'll just go back to that shared directory. You might have noticed when I set up at the beginning that I had a few video files in the shared directory as well. This isn't just a mistake that was included in my demo. I wanted to show you that transferring these large files will show increased network usage. So we'll just copy this and we'll just copy it to the C drive on the local computer. So it's copying right now, and we'll see here the bytes received has gone way up, and we're actually seeing the bandwidth, because it's a virtual cluster, is quite high. I can't comment on how effective the transfer rate would be on an actual cluster, because that would all depend on the hardware setup. So that completes the demo of the Overseer cluster monitor. If you have more questions, please feel free to contact me, and make sure you consult the paper, because it does have lots more information on all the technical aspects of everything I've shown you today.